Guys, I'll be right with you. All right. So give me just a moment. I'm trying to get one more thing to display properly. Once that shows the right way, then I think we'll be ready to go. While I'm trying to get that to load properly, let me see if I can think of announcements and like multitask. Let's see. So we're in week 7. We're kind of, oh no. We're kind of like, not, I don't want to say the home stretch, but there should be like a rhythm. Where basically, you know, we meet. My intent is for class time to be an opportunity for you all to ask questions. I just go through the homework because, you know, students don't request anything. But if you did, we can go through that. I try to get the video lectures loaded in advance. Come on, I need this to display properly so we can move on with our lives. Yeah, we can anticipate exam 2 next week. It should open up like next Wednesday and be due that following Sunday night going into Monday. What else could I do to get this to show properly? It seems like it always just has to like warm up. I have to keep like unplugging and plugging it back in. While we're letting that do what it do, let me check the chat. So if you have questions or anything of that nature, feel free to either type in the chat or unmute yourself. I am monitoring those platforms. So with that being said, again, while I'm still trying to get this to load properly, we're going to go ahead and hop into the assignments for today. I was successfully able to make a video for this. It might be a little bit choppy, but it is there. Let me check the chat. Yeah, I just got to update the quizzes. The quizzes will be short. I'll get those loaded. I usually don't do more than like 5 questions. It should take you like a few minutes. It's just something that's a little bit more along the lines of like the exams, because you know the exams you don't get all the support like with the homework. So just whatever you see that's on Pearson, that's what I need you to kind of work on, and I'll get the quizzes loaded as soon as I can. I just need to update stuff. Yeah, I can't think of anything else. I think the gradebook still needs some tweaking. I'm not used to like linking the grades to Blackboard, so that's kind of the delay. And usually, now I have to go back and look at the syllabus. Usually what I do for grading is like the homework might be like 10%, quizzes might be 10%. I think the exams are usually like 60 and the final is like 20. I think that's usually how I do it, but I had to go back and look at the syllabus, and I'll get the weight to match. Let me see if I can get this student some credit. Who is this? This is okay. And yeah, like part of the delay is like QuickTime. I don't know. It has a this presentation mode, but I don't know why it doesn't just take effect. It seems like it takes a while for it to like get up to. It's all like timing, and like if I do it too early, then it causes the computer to overheat and crash. If I do it too late, then you know we're late for class. Okay, I'm gonna go ahead and reboot the tablet. Sometimes that usually fixes it, gets it to behave properly. And while that's rebooting, we'll go ahead and get started on the problem set. And again, if you all want to work over any specific questions, other questions, or things of that nature, just either feel free to unmute yourself or type in the chat. So this section 3.6 on marginals, differentials, and linearization. Let me see. I don't want to. My explanation. Okay. Yeah, I don't want to go into. I want to just kind of rely on the pre-recorded lecture that I made. But we're making a correlation between the derivative and the slope when you have a second point that's really, really close to the first point, right? So whenever we consider a second point that's close to the first point, the slope is an approximation for the derivative. Remember that the derivative is the slope of a tangent line at a point, right? But then if we introduce a second point that's really close to the first point, then that's where this the differential, I think it's like the dy by dx and that kind of stuff comes into play. So we're making a correlation between the derivative versus the slope with a nearby point. Let's see, that's still showing there. Okay, let's see. Okay, I'm gonna let that do what it do, and let's kind of look at. Yeah, it looks like it's behaving properly. Okay, it's looking good. And then I need to check one other thing. Let me see if I go here. That looks good. Okay. So let's hop back to Pearson and let's get started there. Cool. I was successfully able to do a little bit of multitasking. Okay. Oh, and I think I need to share that for you all. Let me do a new share. And it looks good. Okay, I think we're good. All right. Hopefully the music isn't too loud. And let's just, I'd like to start, because, you know, sometimes these questions, they do be kind of long-winded or like, I have an urge to say wordy or verbose, but I know that's not the right context. But some of the questions are long. But I do want to kind of start at section 3.6. Let me see, without like overrunning my computer. Sometimes if I do too much, it causes it to crash at the most inopportune times. We're at section 3.4, almost there. Okay, here's 3.6. Okay, so let's take it step by step, right? We have this y equals f of x equals 9x cubed, x is 4, and then so this triangle x, that's called delta x. It just means a change in x, right? So the change in x in this case is 0.09. We're asked to find delta y. Let me think about it. Okay, for the given x and delta x values, let me think for a hot second. What formula? Oh, so in the presentation we were, let me see, that's not what we're doing here though. Okay, so for the change in y, usually it's like basically y2 minus y1, right? It's the change in your y values. So let me take some notes and I'll kind of walk you through this one. But again, those triangles, those triangles are called delta, and they just mean a change, all right? So let me take some notes, and we'll walk through this. Let me change my paper. I like graph paper. Let me check another thing. I think my audio is okay. Looking good, okay. All right, so this is question number 10. Hope everyone is doing well. This comes from section 3.6.1. Okay, let me see. So for y equals f of x, which equals 9x cubed, we also have that x equals 4, and the change in x, or delta x, equals 0.09. That delta is the Greek letter delta, like just like the the Greek fraternities and sororities. Okay, so part A asks us to find delta y for the given x and delta x values for the given x and delta x values. I'm just taking notes right now. Part B asks us to find dy equal to f prime times dx, okay? So I'll talk about that when we get to that part. And then C asks us to find dy for the given x and delta x values. Let me see. For the given x and delta x values. I might have to look at the notes to kind of get it, but I'm going to attempt it without it first. So if we hop over to the tablet. So delta y is the change in y, right? So you can kind of consider that one like y2 minus y1, right? So then for part A, the second y value is going to come from, basically what we're going to be doing is f of x plus delta x, that's like y2, minus f of x, right? And we're just going to plug in the corresponding components. So this is going to be f of x is what, 4, delta x is 0.09, and then we want to do f of 4. So this is going to be f of 4.09 minus f of 4. So notice we have two y values. Two different x's are going to produce two different y values, and we're going to find the change in y. So when x changes by 0.9, we're going to see how the y changes. All right, so if we plug these values in, this is going to be 9x cubed minus 9x cubed. The first x is 4.09, and the second is 4. At that point, it's a calculator problem. I'm going to use Siri. Hey Siri, what's 9 times 4.09 times 4.09 times 4.09 minus 9 times 4 times 4 times 4? Okay, I think that's accurate. 1, 2, 3, 1, 2, 3. We got 39. She said about, that's an approximation. Okay, so we're gonna go with this for now. I said it that way because I felt like that was the easiest way for Siri to understand what I'm saying, because sometimes she don't recognize like powers, but she can do math. She can actually do like some other things. I think she can do differentiation. She can do some things, right? You just got to try and see what she can do. I'm going to go with that for now, and I'm going to look at part B. So part B asks us to find dy using f by finding f prime x dx, right? Okay, so the original is y equals 9x cubed. Let me drop down to the second page. The original was y equals 9x cubed, right? So what we're going to do here, we're just going to take the derivative, but this is a technique, I think it's called implicit differentiation, where basically whenever I take a derivative, I'm going to write either dy or dx, right? And it's almost like another term or factor that you're multiplying by. It's called the differential. Again, I'm just going to rely on the video lecture to kind of go into more details, but we're essentially just taking a derivative here, all right, to kind of keep the confusion to a minimum. Okay, so if we just take the derivative here, we're going to have dy. So again, the derivative of y is usually dy by dx, but I'm trying this technique called implicit differentiation. So then the derivative here, if the 3 comes down, that's going to be 27x squared times dx. And again, it's not, that's fine for now, right? So then I think part B asks us to find dy, which is going to be f prime dx. Let me see. Now in the notes, it says that dx is, for our purposes, is going to be equal to delta x, right? So what we're going to do, that means that our dy should be 27 times 4 squared, and then the dx is essentially, for dx is going to be equal to delta x. We're going to just do that. And I think delta x was 0.09. Okay, so then we're going to crunch that number. Hey Siri, what's 27 times 4 times 4 times 0.09? Okay. So in part A, we found the change in y. We found the differential of y. Notice they're close, and I think that's how it's supposed to be. We're going to go with it for now. Let's copy And if it's not right, we'll get to the bottom of what we're the error in our logic if it's not right. And then part C asks us to do find dy using the given x and delta x values. Let me think about it. For the given x and delta x values. I feel like I might be missing something because I feel like I already did that.